Hello, calculus students. I wanted to do a quick little video to go on top of what we've been doing today with the formal definition of limit. So I wanted to do a problem where we're asked to actually prove, and I just made these numbers up. I kind of kept them positive to keep it simple, but I tried to make them all a little bit different. So let's say that a question like this were to come up and we were asked to prove this limit, which I hope you would agree that that is true, that that is the limit. In fact, it's probably not a bad idea to identify things here. F of x is 3x plus 7. L, the limit, is 13. And C, the value that we're approaching, is 2. Furthermore, it may not be a bad idea to just go ahead and mention our key equations or inequalities. F of x minus L is less than epsilon, and 0 is less than the absolute value of x minus C, less than delta. Those are the criteria. So that's what we got to do. So basically, if someone challenges you on this and says, prove to me that that's the limit, and you want to use this delta epsilon definition to verify that, this is the important criteria. So basically, they would provide you some epsilon, and then you just got to figure out the delta. But what we're going to do is we're going to prove it for all epsilon, which is basically proving the limit. So let's go ahead and start. First things first is we're going to start by figuring out what our delta is going to be. That's crucial. So we're going to start with our, f of x minus L, which in this case is 3x plus, and I think it was 7, minus L, which I think we said was 13. And then that has to be less than epsilon, right? So then we've got, of course, that 3x minus 6, which is the same thing as 3 quantity x minus 2, which again, this is less than epsilon. So now we can divide this 3 over here. So we can say that x minus 2 has to be less than epsilon over 3. Now here's the key crucial point. This will be our delta that we're going to use. So whatever epsilon they give us, we just want to divide it by 3. As long as we divide it by 3, we're going to fall into that range. In fact, if we pick anything less than epsilon divided by 3, we'll fall into that range too. So I guess what I'm saying is by the fact that we know we've got this other inequality, x minus c less than delta, well, in this case, c was 2, so this is going to be 0 less than the absolute value of x minus 2 less than, well, the delta. And what is our delta here? Our delta here is epsilon over 3. So we know that's going to work. That's going to interchange. But let's go ahead and finish the proof over here. Again, this was the key. So now what we can do is, again, we're going to go back to our, our f of x minus L, which is going to be 3x plus 7 minus 13. And that is equal to 3x minus 6, which is 3 quantity x minus 2. And what is x minus 2? Right? So I can literally at this point say 3 times, and instead of x minus 2, I'm going to put in epsilon over 3. And guess what happens to our 2 3's? We get our epsilon, which was what we needed to provide. In other words, it doesn't matter what the epsilon is, the limit is going to be 13 because it exists.